Okay. Good morning, everyone. Myself, Seiko Jose. I'm a scientist in textile manufacturing and textile chemistry division, ICR Central Ship and Wool Research Institute, Naviganagar, Rajasthan. Today, I would like to give a presentation on preparation and characterization of coarse wool fabric reinforced natural fiber latex composites. So here is our team, myself and my professor, Sabu Thomas, Mr. Jibin KP, and Dr. Vinod Katam. So just I am giving to an introduction about Indian sheep breeds, especially the topic will be new to you people. So some of the sheep breeds of Indian subcontinent are Deccani, Patanwadi, Malpura, Nellore, Vambur, Gadi, and Mandya. Now, classification, just I am giving a classification to the wool fiber, how it is getting classified. So, wool fiber is classified into three types based upon its diameter. First one is fine, which is having below 20 micron, and especially it is using for carpets and textiles. Second, wool fiber category belongs to carpets, which is having a diameter of 20 to 40 microns. And third one, the very coarse, or it is also known as Kempi fiber, which is having more than 40 microns. It is still underutilized. So my objective is to utilize this particular specialty, wool fiber, which is of no use. Because as you know, these sheep rearers, in fact, they are not getting even the market price for their shearing cost itself. So my intention is to give a value addition to this wool fiber through natural rubber for polymer composites. Now this is the Patanwadi coarse wool which I have taken for my study. Now this is the process what I adopted. Here you can see I have taken initially I took one wool fiber, then it was converted into wool fabric, and later natural rubber latex was coated on that one. It was used to remove the excess latex, and further a characterization was done. Finally, it went for making some products. Now you can see this is the recipe which I used for the compounding of rubber latex. You can see 60% DRC rubber latex was taken, and it was mixed with 10% KOH, 50% iron dispersion was added, and sulfur, ZDC, zinc oxide, all these are in required concentration. Now I took the wool fabric, it was cut into 15 into 15 centimeter, and the compounded rubber latex was poured on that one. And and I have used a hand-driven roller for uniform dispersion, for making a uniform dispersion for coating. The coating was done on both sides, and finally, after coating, it was kept under a compression molding, just to squeeze out excess latex. We have not given any pressure or temperature. This process is not for curing process, only to remove the excess latex from this. So this is the process. Now coming to the result and discussion, these are the physical and mechanical properties of wool fabric in comparison with the wool natural rubber latex composite. So what we observed here is that you can see tensile strength, it is for bare wool fabric, it is 3.1 here you can see, and it is increased to 7.26. 10% of elongation was increased to 56%, because as we know rubber is highly elastic in nature. As a result, the elongation increased. Tensile tear strength also increased to double. Instead of 3.1, it was 6.2. Here you can see aerial density, 600 aerial density became 1200. So which means The composite is having 50% of rubber and 50% of wool fiber inside that. Now this is the stress strain curve. As I indicated, the strength, it is highly elastic in nature when wool fabric was incorporated with the natural rubber latex. Stress strain curve is showing a similar trend. Now this is the diffusion properties. In the left side you can see water diffusion, and in right side it is toluene diffusion. In water diffusion, what I observed, natural rubber latex wool composite showed a very less absorption of water, and wool fabric, in fact, it has shown high water absorption. And because wool is hydrophilic in nature, so it absorbs a lot of moisture and water. In case of toluene diffusion, here also the latex wool composite showed a minimum toluene diffusion in compared to wool fabric. But here you can see in wool fabric, there are pores, so that is why the absorbency is higher. This is the trend, and the difference in between these latex wool composite and wool fabric in case of toluene diffusion is minimal. Now this is the SEM analysis. In the SEM analysis you can see first one, that is the modulation inside the pristine wool fiber. So modulation means there is a hollow space inside the wool fiber. This is known as modulation. So we have taken modulated fiber only, and you can see the hollow space in between inside this wool fiber. And B is the edge of the edge of the wool and our composite. C and D are the cross sectional images of these composites. And what I found that in cross-sectional images, you can see the wool fiber. I mean, this is actually the tensile fracture surface of the composite. And we found that modulation, you can see in the figure D, you can see the fiber modulation. There are some fibers we can see without modulation also. Some fiber deformation is observed because when we applied some pressure, fiber, the oval, that the circular shape of the fiber became oval. So this is another difference what we observed. And the due to tensile strain, that stress what we applied, because of this particular stress, what we observed, there is a interfacial debonding is observed. So that is the breakage reason while applied during applied stress. So these are the observations what we got it from SEM. And we also analyze this aging properties, and you can see the tensile strength, aging properties in terms of thermal aging and UV aging. So what we found that after thermal and UV aging, there is no much differences or significant differences in the tensile strength and elongation. So which indicates that the developed composite is having good thermal and UV resistance. Now we after thermal exposure, the color of the the rubber, natural rubber wool composite is slightly changed into yellow color. So this is because of the property of the wool fiber. When we are exposing the wool fiber into sunlight or even into temperature, the color of the wool fiber slightly change into yellow. This is known as photo yellowing of wool. So this is the reason why the composite changed to yellow in color. Now coming to the conclusions, we analyzed the physiomechanical properties of the composites, and we found that there is a substantial increment in comparison with the bare wool fabric. Now the SEM images showed the penetration of rubber inside the wool fabric, because the latex is penetrating inside the wool fabric, and in the both side we are getting uniform coating. Now thermal and UV aging didn't mark much reduction in the mechanical strength of the composites. And we also performed soil degradation studies. We kept the composites in the soil for 120 days, and we found that only 13% of weight loss was observed. So which indicates that natural rubber, though it is a natural material, after cross-linking or after vulcanization, the there is a restriction in biodegradation. Now, the 13% weight loss after 120 days, what we assume that this is because of the degradation of wool fiber, not from the weight loss is not from the degradation of rubber, because the rubber became very hard, and after vulcanization, it's very difficult to degrade. Now, the abrasion resistance also we checked, and we found that it's very excellent. After 5,000 cycles, we found only 8.45 percentage of reduction in weight. And we also calculate the price for the fabrication of the composite, and it's found to be around 7.5 USD per meter square. So these are about our conclusions, and also we made some products. You can see some of the products which is made out of this. So these are especially ladies bag and clutch bags were developed. So we have developed this one, and we found that it looks attractive, and we also did some subjective evaluation of that. So that's about my presentation. Thank you very much for your patience listening. And I must thank our organizers for giving me an opportunity to share my research finding. Thank you very much.